So we're in OpenStax Statistics, Chapter 12. We're going to talk about a linear regression example with lots of different questions kind of associated with it. So this has to deal with stats exam scores. You can reference the OpenStax text for free. Just look in the description of this video for a link. And you can get a free copy of this Excel workbook at dividingconquermath.com. Just go to the OpenStax Statistics section. So what we have here is we have a random sample of 11 statistics students with their third exam score versus their final exam score. Let's see, I'll space this out a little bit more so you can make sense of it. So we've got the third exam score versus the final exam score. The third exam is out of 80, the final exam is out of 200. Okay, so scattered kind of throughout this chapter are a bunch of different questions about this situation. And so really a lot of this can be interpreted by first just doing what we need to do to analyze this data. And there's kind of two ways on how we can analyze this data. So for kind of our starting questions, what we can do is we can start by making a scatter plot. So I am just going to select all of the data that we see here. I'm going to insert, I'm going to go to recommended charts, and I have this scatter right here. So I'm just going to click OK. Okay, so let's see. Let's put this maybe, let's put this right here for right now. Okay, so there's actually a lot of questions that can be answered just from making a scatter plot. And so the scatter plot's a little incomplete. So what I need to do is I want a regression line in it. So I'm going to click on the dots and I'm going to right click on them and I'm going to hit add trend line. And if I add in the trend line, so now you can see that Excel has created the least squares regression line, and it just automatically done it. Okay, now when I asked it to format the when I asked it to add a trend line, I got this menu of options to format the trend line. If that didn't come up for you, you might just have to right click and hit format trend line. But notice at the bottom here, I have a few other options. So I can write display equation on chart, display r squared on chart, and set intercept. So setting the intercept, we'll just kind of mess around with the scale a little bit, so we're not going to use that one, but these other two are helpful. And so what this has done is this has given me both my regression equation and my r squared. And so I'm going to just note here, so my regression equation, I'm actually just going to write it out so that I don't forget it. So it's going to be y equals 4 let's see, let me delete this here, get rid of that. Okay, so this is y equals 4.8274x minus 173.51. So here is my actual regression equation. So we're asked, can you predict the final exam score of a random student if you know the third exam score? So yes, you can. You can use this regression equation here. So tell me what the third exam score is within reason. And if you plug it in here, then you should, in theory, be able to determine what the final exam score might be. And from here, it also says, so interpret the slope and the y-intercept. And also state the value of r and r squared and interpret the meaning of r squared. Okay, so once again, all of that can really just be determined from seeing this regression equation. So I can see here that my slope is what's attached to that x, so that's 4.8274. And the y-intercept is negative 173.51. Okay, so the questions here are to interpret both of them. So what this means is, so with the slope, so for each point that you make on the third exam, that translates to 4.8274 points, ideally, on the final exam score. So that's what the slope means. So for each point in, ideally then for the final exam, that will translate to 4.8274 points on that. The y-intercept, though, being negative, so this would be the value if I plugged in a 0. So the thing about regression equations is that sometimes the y-intercept makes sense and sometimes it doesn't. And so what this would mean, technically, is if I got 0 points on the third exam, then on the final I would get a negative 173. So this does not make sense. It's not possible to get a negative 173, at least I hope not. So in this case, there's just no interpretation for what the y-intercept actually is. Now, the value of the r squared, that is something that you can see here on the table. I'm going to just move that around just so we can see it. So you've got your r squared, which is this 0.4397, and we're going to compare that to the value of r. And so I can just take the square root of my r squared and get that relationship there. Okay. So we have these two values. Oops, and this is not r squared. Sorry, this is just r. Sorry, Excel keeps auto adding that. Okay, so my r is this. So this is my correlation coefficient, right? And so this is positive, and I wouldn't say it's super close to 1, but it's also not super close to 0, right? So this tells me that there is definitely a positive correlation here among the scatter plots, which makes sense just kind of looking at this. It's just not like a super strong one, right? So the value of your r is talking about the relationship kind of between your points, how closely correlated they are, but r squared has its own specific meaning. So I want to actually highlight that. So this comes directly out of the book or from the slides, and it says, so r squared, when expressed as a percent, represents the percent of variation in the dependent variable y that can be explained by the variation in the independent variable x using the regression line. So in this case, so I have this 0.4397, so we'll round that up to 44%. So we typically take our r squared and we round it up. So we'd say approximately 44% of the variation in the final exam grades, i.e. that's our y, can be explained by the variation of in the grades of the third exam using the best fit regression line. So this is usually the way that we kind of set up these explanations. We set it up as a percent, and it's always the percent of variation in whatever your y variable is that can be explained by the variation in the independent variable. So this is just always kind of the format of like how you will end up describing that. Okay, so that has gotten us these first two questions here. So now moving on, so we'd say, what would you predict the final exam score to be for a student who scored a 66 on the third exam versus a 90? Okay, so what that's asking me to do then is it's asking me to plug in a 66. So I want to plug x equals 66 into my formula versus x equals 90. So let's compare those two things. So I'm going to use this regression equation here. So that's 4.8274, and now I'm going to plug in for x. I'm going to plug in this 66 and then minus 173.51. So there is me plugging x into that, or x equals 66 into this equation, and let's compare that to 4.8274 times 90 minus 173.51. Okay, so if you got a 66 on the third exam, we would predict that you'd get 145 on the final. And if you got a 90 on the third exam, we would predict that you get a 260 on the final. But remember, the final is really only out of 200 points. So we can see that using this x equals 90, this is a little bit odd. And so why is that? Well, one of the things you have to be careful with regression is that the values that they plug in, they need to be like within the range here. So notice that my values, is as I look through this, the lowest value that I have data on is at 65, and the highest value that I have data for is a 71. So using x equals 90, that is considered to be like, that's not really in that range that we're working with here. So this is a large value to input. And so if you're not inputting in values that are kind of within this range, then you might get nonsense numbers. And so in this case, I would think this is probably not a reasonable expectation. But for this x equals 66, I got a 66, and I think I'll get a 145 on the final. That's probably reasonable, and that kind of falls within that range. So it's an imperfect way to describe this, but that's how you can kind of interpret your intuition for all this. Okay. So now let's move on to a slightly different set of questions here. So we want to talk about outliers. So we want to prove that this data set has one outlier, and we're going to create a table that compares the output of the regression to the actual values to determine if any outliers exist. And then we want to remove the outliers and compute our regression equation again. So what I'm going to do here is now I'm going to just delete all of this. I'm going to delete all of this. And so now what we're going to do, let's see, I'll move this over here. We're going to use another special feature of Excel. So I've cleared everything out to give us a little space now to work with this because we're going to need a different feature. So hopefully you already have this, but let's go into this tab here that says data. So what we're looking for is we're looking for this data analysis tool. Now if you don't have it, I'll just walk you through how to do this right away. So if you go into File and then Options, you will go into where it says Add-ins. So click on Add-ins. And then where it says Manage Add-ins down here, you'll click Go. And you want to have I would just check both analysis tool packs here. So these both need to be checked. If they're not, then check them and then hit OK. And ideally, after you do that, you should see data analysis here. I think sometimes people have to restart Excel to see that, but in theory, you see data analysis. So now that we have data analysis set up, we're going to click on it. And so this is kind of exciting because there's a lot of different things here that Excel can do that are like stat specific things. So what we're going to select is we're going to select the regression. Okay, and so now Excel has brought up this little program and it's going to do something kind of special for us. So it says input Y range. So you can see here that I've organized my data into X's versus Y's. I'm going to select this whole set of Y values, but notice that I also select the label. So what I'm going to do is I'm going to have to check labels here. If you don't select the label, you don't have to check labels, but I typically will select the labels to go with it. And now I'm going to do the same thing. So where I have this input X range, I'm going to select my X's. I selected it with the labels and we're good to go. Okay, so Excel is going to do some kind of cool stuff. And what we wanted to do is we wanted to do the output on this sheet. So we're going to select where it says output range, and then it's just asking for where do you want me to put this. So I'm going to click on this box here, and then I'm just going to click on this cell right here, and this is where the output's going to come. And the last thing that we're going to have Excel do is we're going to have it take a look at just some of these different plots. So I'm just going to select all of these values here, and then I hit OK. And so here is what we get. So we get a bunch of different stuff. So Excel has just computed a whole bunch of interesting stuff. Okay, so this has now run for us actually a whole test on regression. So notice what we get for our output. I get my R, which is the same R that we found a few minutes ago, right, when we were just playing around with the scatter plot. I have my R squared, which is the same. I can see how many observations I have. We got a ANOVA test out here, which probably doesn't mean anything to us, but also look what we have down here. So I have a t-stat and a p-value associated with both my y-intercept and my x's. So Excel is doing different types of statistical testing and giving you p-values just as an option. And also if you scroll down a little bit more, you'll notice that Excel has this thing called residual output. And this is the part that we need to answer that question regarding outliers. So one way to determine if you have an outlier is to look at the residual output from your linear regression. And so as I look through this list here, I notice that this value, this is greater than 2, and that's very often the cutoff point. So if it's greater than 2 for your standardized residual, that's what indicates that you have an outlier. So that's my first observation. And so that's really what I'm being asked to do. You'll notice that Excel also gave us these other graphs. So if I just blow them up a little bit. So this is looking at a residual plot in another way. And so this is another way that you can visualize outliers. So specifically, this value here would be the outlier, and that's going to correspond to the one that we found down here. So this value, according to the residual plot, you can see how it's kind of sticking out, so that is definitely an outlier. So Excel will automatically do the residual plot, and then if we play around with this graph here, if I just blow it up a little, so this is the other interesting thing that Excel just will automatically do. So Excel has taken the scatter plot, which is the blue dots, and then it has compared that to what it thinks it should have predicted for these values. So the blue dots are the actual values, and the orange dots are what Excel would have predicted based off of the data that we gave it. So it's another one of those things where we can kind of see, it's another way we can visualize our outliers. So I can see there's kind of a large distance here, so that's telling me that that's also an outlier. But this is just another way to kind of understand and look at the data. So I'm just going to delete that for now. So that was all found in that data analysis. And so now we have done the task of proving that this data has one outlier. We have made that table. And so we have found the outlier right here. And we're asked to remove the outlier and compute the regression again. So this was the first observation. The first observation was our outlier. So what's really cool about having this scatter plot here, so watch what happens when I go through and I delete this value. So watch my scatter plot down here. So what Excel has done is now it automatically redid my scatter plot, and from that it also automatically came up with a new regression equation and a new r squared. And so you can see that the r squared is higher, so then what that's going to mean is that means that my r will also be higher, so this is indeed a stronger correlation. Now I do want you to note I deleted the value from here and all of this changed, but none of the data over here changed. So this can only be changed by rerunning that statistical program that we just had. But by doing all of this, we were able to see that I can safely delete this one value here and get this new output. So it's kind of a back and forth between the two things.